All right, welcome back. Today we're going to go through section 6.4, which is all about rational exponents. Our EQ is, how can I write a radical expression, which is what we just quizzed on, using exponents instead of radicals. So what we're going to see today is how can we get rid of the radicals and just use exponents instead. So what we are going to do is, for the warm-up, right, since we're going to be working with fractions, let's just remember how to combine fractions together. For all of these, you could use the calculator. You don't need to do this by hand, but just as a quick reminder, 2/3, if I'm subtracting 5 over 1, that means that I want to, in order to add or subtract fractions, I need a common denominator. So I'm going to achieve that by multiplying here by 3 on top and bottom. What that allows me to do then is write this as 2/3 minus 15 over 3. And then with fractions, if I have a common denominator, I am just going to combine the numerators together, or the tops of the fractions. So 2 take away 15 is negative 13 over 3. Okay. On the calculator, that looks like, on here, you could just type in 2/3 minus 5. And then we know you can do math, enter, to turn a decimal into a fraction as well. So again, just going to do these by hand so we can kind of remember how fractions combine, but at any point in time, just use your calculator to combine these if you're unsure. When I'm multiplying is a little bit easier. All we're going to do is multiply the numerators together, and then we're going to multiply the denominators together. If I do that, 3 times 5 is 15, 2 times 3 gives me 6, and then I'm going to look to see, can I reduce this fraction? 15 over 6, I can divide both the top and the bottom by 3. So if I do that, divide by 3, my simplified fraction is 5 over 2. Yeah, 5 over 2. And again, we're not gonna turn that into 2.5. Some of you have learned to write as improper fractions, to write as mixed numbers. But we're gonna leave it. If you have an answer of 5/2, it's just a lot easier to do algebra if we keep it 5/2. And then finally, again, if we have an adding, it's the same as subtraction. I need these denominators to be the same. So what I'm gonna do is I'm gonna multiply by 2 on top and bottom. Get out of here. Okay, and what that's going to allow me to do then is write the first fraction as 14 over 4 plus 3 over 4, and that'll give me 17/4. 17 and 4 don't have anything in common, so then that is our fully simplified. Now, not too much of what we do will be based on. We'll just be combining fractions, but that's part of what we're going to do today. So just to kind of get into it, this is something that you may have already picked up from the previous sections. If I want to take a radical and write it as an exponent, I can simply take the index of the radical. Remember, the index is whether it's the square root or the third root. And I can write that as the denominator of the power. So the index of the radical, if I want to write it as a radical instead, I can turn that into the denominator of the power. Yeah, buddy, I know. Okay. So, for instance, if we have the square root of 36, that can be rewritten because we know that is we know that's a index of 2. That can be written as 36 to the 1/2 power, where this 2, instead of writing a radical, becomes the denominator of that exponent. Same sort of thing if we have the cube root of 125. This is equal to 5. Like, we know you could type this in the calculator and it's equal to 5, but it can be rewritten as 125 to the 1/3 power. The key here is that this is all in exponents. So if you want to put parentheses around this to make it obvious that the exponent is 1/2, feel free to do that. And actually, when we type it in the calculator, we do need to put those parentheses around the power. So it's a good idea just to get in the habit of that right away. And then same sort of thing for 256. Instead of writing it using the radical symbol or the fourth root, I can write it as 256 to the 1/4. The key here is that if you're going to write it as an exponent like this, the radical is no longer in the picture. It is gone. It is completely out of there. So index of the radical turns into the denominator of the power. And we're going to see how that works for a couple other things here. So if I have 27 to the 1/3 power, this is what we would call exponential form because it's written using an exponent. I want to turn it into a radical or what we call radical form. So 27 to the 1/3 power. Again, if I'm going to take this denominator, and I can also write that as the index of the radical. So instead of 27 to the 1/3, I can write this as the third root of 27, which we know is equal to 3. Again, just to kind of show you how this works in the computer or in the calculator, you can either do the third root, so 3 math 5, the third root of 27, and I get 3. Or I could also do 27. And here's where you have to be careful if you're going to type it in as a power. Some calculators don't require you to use parentheses. Some calculators do require you to use parentheses. So we're just going to assume that we need parentheses because that'll keep us safe in all situations, no matter what device we're using. Either way, 27 to the 1/3, I get that same answer of 3. So now if there's an exponent, like here, every example so far has had a 1 in the numerator of the power. Here, if it's 8 to the 4/3, I'm still going to take this 3 and turn that into the index. So this is going to become the third root of 8. And I have two options here. I can either raise 8 to the 4th power before I take the third root, which I'm not a huge fan of, or instead I can put parentheses around this and then raise it to the 4th after the fact. And I prefer this when we're dealing with numbers because the third root of 8, right, this value in here is something that I know. That is equal to 2. And then I can just simply in the calculator or in my brain do 2 to the 4th power, and that is 16. Okay, so if I were to type in the calculator 8 to the 4/3 power, I should get a result of 16. And we can double check that real quick. This will be the last one that we do. If I want to do 8 to the power of, again, in parentheses, 4/3, I hit enter, and then I get 16 as the result. This last one here, here's where we're going to bring into some new math into play. If I have 49 to the 1/3 times 7 to the 1/3, when we talked about exponent rules, these couldn't be combined unless they had the same base. But what we see is if we write this 49 to the 1/3 as the third root of 49 instead, and 7 to the 1/3 as the third root of 7. Now we can combine them using what we already know. They have the same index, so I can multiply the radicands or the numbers underneath. So I can do 49 times 7 and get 343. This is a perfect cube. This is simply the third root of 343 is equal to 7. So that allows us to simplify all the way down to just a single digit 7. No power, no funny business or anything like that. So if you have something has a fraction exponent, you can either rewrite it as a radical or type it directly into the calculator. Sometimes we'll want you to simplify, and sometimes it does come out to be a nice number, and sometimes it's not so much. So go ahead and pause if you want to try these three, writing them from exponential into a radical form or using the radical symbol. And in order to do this, we're going to, again, focus on that 4. That's going to become my index, the 4th root of 16. Again, you can either put the third power right next to the 16. I'm going to do it like this instead. So I'm going to take the 4th root of 16 and then raise that to the third power. The 4th root of 16 is 2. So 2 cubed is 8. Bam. Easy as that. Again, you could type in the calculator, but we want to kind of see where the stuff's coming from and why it is what it is. For this, 25 to the 5 halves, that means my index is going to be 2. So you can put it there or not. It's the square root. Whoa. I'm going to take the square root of 25. Sorry about that. Square root of 25. And then I'm going to raise that to the 5th power. We know the square root of 25 is 5. 5 to the 5th, I believe, is 3125. We're going to double check that real quick. 5 to the 5th. Yep, 3125. And then we can finish this last one. Now, here's where I write it differently. If it's a variable, because I know I'm not going to be able to type that in the calculator. Regardless, I know this is going to be the third root. And then because we have a variable, I'm going to go ahead and just lump the power or that exponent of -2 in with the x underneath the radical sign. I could write it instead like this. But since we don't know the value of x, and that's not something we can type in the calculator, I prefer to just lump it in there right away. Now, this does go back to what we learned about exponent rules. I can't have a negative exponent in a final answer. So what I'm going to do is I'm going to write this as the third root again. But I'm going to take this x variable, and I'm going to move it down to the bottom of the fraction and switch that exponent to positive. So the way I would want you to write x to the -2/3 would be the third root of 1 over x squared. Okay. Again, there's no more simplification we can do with this. We got rid of the negative exponent and we changed it into a radical. So we're good to go there. Again, if you want to pause real quick, now this is the opposite. So this is taking something that's written in radical form and writing it as an exponent instead. To do this, again, it's basically just backwards. I'm going to take my index, and that's going to become the denominator of the exponent here. So this is going to become 7 to the 5/4 power. Okay. Again, if you want to throw parentheses just to make clear that that is an exponent, I'm going to try and type that in. I know the 4th root of 7 isn't a whole number. So I can try this just to get an idea of what the value is, but I'm not gonna rewrite it as 11.38 around that or anything like that. So we're actually gonna leave it just like that. Here, my index is 2, so I have the square root of 11 raised to the 6th. Notice in the previous example, the exponent of 5 was underneath the radical, whereas here the exponent is outside the parentheses. Fair game, you're going to see it both ways. Just understand that that's asking the same thing. So here I'm going to write this as 11 to the power of 6 over 2. Now, if you find yourself in a situation where you know this exponent can be simplified, 6 over 2, 6 divided by 2 is just 3. I'm going to rewrite this as 11 to the 3rd power. And then if that's just something I can type in the calculator, 11 to the 3rd power ends up being 1,331. Okay. So when you turn the index into the denominator, if it makes a fraction that can be simplified like 6 over 2, go ahead and do that. Finally here, we have the third root of 8 to the 4th power. Now, we already know the third root of 8 is equal to 2. So I could just rewrite this as 2 to the 4th. But again, we're just trying to get the practice of switching from radical form into exponential form. So this would be 8 to the power of 4 over 3. And then sure enough, if I type 8 to the 4/3, I think we already did that one earlier in the video. 8 to the power of 4/3, we end up with just 16. So again, right now I'm more concerned with being able to switch back and forth between radical and exponential, so that way we can see the relationship that that exists between the two. So for this, I can just write this as 16, which is fully simplified. But again, making sure that you can transition to and from exponential form and radical form and vice versa. So that's that part. Now, again, we're going to kind of look and see what happens with some of the problems that led us to dead ends earlier in the chapter. We can actually do stuff with it now. We learned in section 6.2 that in order to multiply two radicals together, their indexes had to be the same. So what we would have done is we would have said this can't be simplified because it's the 5th root and the 4th root, and those aren't compatible. But now that we know what we know, I can write both of these as exponents instead. So the 5th root of x to the 2nd, I can rewrite as x to the 2/5. Okay, so that's a power instead. That's the exponential version. And then here, the 4th root of x to the 5th, I can write as x to the 5/4. So now that I've written them both as exponents, we know our exponent rules say as long as I have the same base, I can combine these things together by just adding their powers, right? We've done that throughout chapter 6. So what I'm going to do is I'm going to jump to the calculator and I'm going to take 2/5 and I'm going to add that to 5/4. Again, just going to, if you want to do it by hand, you can, but I'm not going to require you to do that. 2/5 plus 5/4 is 1.65. That I don't want. So I want to get it as a simplified fraction of 33/20. So then I'm going to go back here. That means this can be written as x to the 33/20. And then if you had to write it in radical form, we could change it back then and say this is the 20th root of x to the 33rd. And then depending upon how far you want to go, and depending upon if you're looking at other videos or other like Slater or something online that gives you the answers, they might break this down just like we did. Let's be clear. For now, I'm good if you can get to right here. Either one of those answers is fine. What you may see online is that they break down that x to the 33rd into the 20th root of x to the 20th, because I can do 20 divided by 20, and then the 20th root of x to the 13th. If these last 30 seconds of this slide, you're thinking, what in the world is going on? Again, don't fret about this too much. This is just to kind of get it to full math, like breakdown. This is extra work. And as we go, we might start to ask you to write it like that. But for right now, our focus is that when I write them as exponents of 2/5 and 5/4, I can add those together. Same sort of thing here. If it's division, we know that I'm going to end up dividing, or sorry, with division, I'm going to subtract the powers. So I can write this as x to the 3/4 and x to the 2/6. And I know that 2/6 could reduce to 1/3, but I'm going to have to subtract these powers anyway, so there's no, I might as well just go to the calculator and let the calculator do it for me. So 3/4 minus, I'm going to clear that out, 3/4 minus 2/6, decimal, math, enter, and I get 5/12. So I can subtract these things, and this would become x just simply x to the 5/12, no fraction anymore. And again, if it was a multiple choice question and it only had radicals, using what we know now, we could switch this to the 12th root of x to the 5th power. Either one of those, totally fine. Again, read the directions as you go. Sometimes it'll ask for the answer in exponential form, sometimes a radical. And if it doesn't specify, you can really write it in either form. So, yeah. So if it's a product or a quotient and it's not the same index, go ahead and switch it to exponential form, and then we see that it's something we can combine. Again, now we're just going to kind of get into a couple more examples. I think there's only 2 left. Yeah, only 2 more that we're going to look at. How do I do power to a power, which is something we have already done in section 6.0. But what do I do now if it's if the exponent's a fraction? So I see that I have the power of 3/4, and that's applying to everything in the parentheses. So to the 81, to the x, and to the square root of y. It's a little goofy to have both fractional powers and radicals in the same one. So when I write this out, 81 is going to be raised to the 3/4. That I'm going to go to the calculator for. I have x to the 3/4. And then I'm going to go ahead and switch the square root of y. We know the index is a 2 there. So instead of writing it as square root of y, I'm going to write it as y to the 1/2 power, right? Because we know now that the square root and the 1/2 exponents are the same thing. And then I'm going to put the 3/4 power out here. Okay. And I'm going to go to the calculator, 81 to the 3/4. Again, even though I put parentheses around the 81, which isn't strictly necessary, if I'm going to type this in, I got to put the parentheses around the 3/4 just because I don't know if my calculator is going to work with it or not. So if I do 81 to the 3/4 in the calculator, I should get 27. If you get some crazy high decimal, then that's how you know you typed it in incorrectly without those parentheses. So that's that first part, x to the 3/4 power. There is no exponent with x, so I can just write it as x to the 3/4. And then y to the 1/2 to the 3/4. What we know about our exponent rules is if I have a power and it's raised to another power, I'm going to multiply those together. So I'm going to multiply these fractions. You can use a calculator. Again, all I need to do to multiply is multiply the tops and multiply the bottoms. So 1 times 3 and 2 times 4 means I'm going to have a power of 3/8 for y. At this point, we're not going to try and write it all underneath a single radical. We're not going to do much else with it. As long as I don't have any negative exponents, this is going to be our final answer. So we'll write it just like that, 27x to the 3/4 and y to the 3/8. Some courses might have you go further with it, but we're going to leave it like that. And then finally, what happens if I have a negative power with it? What we saw when you have a negative exponent outside of an expression is that that's going to make everything negative, which means I'm going to have to, everything's going to end up with a negative power. So what I'm going to do is I'm going to go ahead and put this over 1, right? I can make any expression into a fraction by putting over 1. Then what I'm going to do is I'm going to go ahead and just flip that fraction on itself. So I'm going to flip the top and the bottom. So it's going to be 1/8x to the 15th power. So just wholesale, top to bottom, bottom to top. Don't change anything inside the parentheses, because then what I'm going to do is change that power from -1/3 to +1/3. And now I'm just going to apply the 1/3 power to every piece of it, to the 1, to the 8, and to the x. I know 1 to the 1/3 power, that's just going to be 1. If I have 8 to the power of 1/3, that's the same as the 3rd root of 8. So that's going to end up giving me 2. And then if I have x to the 15th, just as a little side calculation, those are the dogs in the background. If I have x to the 15th power and I'm raising that to the 1/3, I'm going to multiply because of power to a power. 15 times 1/3 is going to give me 5, so that's going to be x to the 5th. I don't have any negative exponents. I can't reduce 1 over 2, so I know I'm good to go there. Okay. These aren't all the examples that you'll see, and this isn't a comprehensive list of the things that we'll do. But again, just as you encounter fractions that are exponents, know that that's where radicals come from, and vice versa. If you have a radical, you can switch it to an exponent. Our summary, our EQ is how can I write a radical expression using exponents instead of radicals? So basically it all comes back to slide 3, I think. We're going to use the index of the radical becomes the denominator of the exponent. Again, I like to just give an example to go with that because that's a lot of mathy words, and if you just read that summary out of nowhere, try and explain it to someone, that might not make a whole lot of sense. So let's do the third root of x to the 5th power. We know we can rewrite that now as x to the 5/3 power. And that's basically what today's lesson comes down to. We'll do more with this as we go, and now going further into chapter 6, we'll be doing more with solving equations that have these radicals or these fractional powers in. But today is really just about the transition between them. The homework for 6-4 is 12 to 66 every third problem. I know it sounds like a lot, but it's not as bad as you might think. That about does it for this first section back of chapter. What are we at? First section back in chapter 6 for the second half. So yeah, have a good night, and we'll see you next time.